Good morning everybody. So today we are going to discuss the decimal to binary conversion and binary to decimal conversion. So first of all, the overview of today's presentation will be why do we need decimal number system, why we need binary number system. Okay. So why do we need the decimal number system, and then why we need the binary number system. We will be focusing on that, okay, these 2 points, and then why we need to convert. Okay, so before we start studying anything, first let us discuss the importance of why we need to study all this, okay, and also why we need to convert from binary to decimal. Okay, so first, why we need the decimal number system. Okay, we humans, we have been using decimal number system because if we have to count, we have been using our fingers to count, right? Okay, 1 2 3 4 5 6 7 8 9 10, we have 10 fingers. Okay, most of us, we have 10 fingers. Okay, deci, the meaning of deci is 10. Okay, the meaning of deci is 10, right? So that is the reason we humans, we use the decimal number system because we have 10 fingers, right? And it became a sort of global standard. Okay, right? The decimal number system has become global standard. If suppose somebody are talking about, let it be trade, okay, if they are giving the numbers related to the trade, they are using the decimal number system by default, right? Okay, and then let it be computing, let it be science, let it be engineering, finance. Okay, whenever we say a value, or let it be measuring, if we say 100 centimeter, okay, then we are telling that the 100 is in decimal by default, or let it be constant, okay, or let it be any measurable or non-measurable quantities, even calculations. If suppose somebody will ask 5 into 2 is how much, okay, by default, even from your school days, you are doing it in decimal, okay, number system. And also communication, whenever you want to communicate, right, you want to express anything, you also make use of the decimal number system, right? Okay, so it has become global standard and we humans have been widely using the decimal number system, right? So that is the reason we need to study the decimal number system. Now what about the binary number system? Now if you see, okay, what a computer has, a computer has very tiny switches, or also it has very tiny storage elements. So now the storage elements, okay, right, it is easier to store smaller information like say 0 or 1. The advantage of that is the, okay, complexity and size of the storage element will be reduced. Okay, right? If we store very small information, the basic unit which stores that information in the memory, okay, that size is very small and also its complexity is small. Fine. Not only that, if you see the electronics, let it be computers, mobile phones and so on, okay, the logical devices, now these, they consist of billions of tiny switches, okay, called transistors. Now a switch has only 2 possible states, it could be either on or it could be off. Okay, a switch has only 2 possible states, the switch can either be on or it can be off. Okay, right? So that is the reason, because a switch has only 2 possible states. Now binary, bi, you know very well, whenever we say bi, it is 2. Okay, bi stands for 2, right? So it has 2 states, on or off. Each switch within the computer has only 2 possible states, one is off, another is on. Hence computer makes use of the binary number system. Okay, now because we have 10 fingers. In the previous slide we have seen that decimal number system has become a standard what we humans use. Likewise, the standards for computer has become the binary. Okay, the binary number system has become the basic standards of the computer system. So, not only that, if you see Boolean logic, okay, if you see the Boolean logic, now Boolean expression can either be true or it can be false. Okay, only two possible states. Now, the switch, the basic component within the computer also has two states, on off. So, it is straightforward to implement Boolean logic using the binary number system. Okay. Previous slide we have seen what are all the cases where decimal number system has become a standard. Now we are going to see where all binary number system has become a standard. It is in digital communication, okay, arithmetic. When computer has to compute, it will compute in the binary domain. Okay. Now whatever result it has got, if it wants to detect the error also, it can perform all its operation in the binary domain. Okay. And encryption in zeros and ones, okay, you can have a series of zeros and ones. For data security you can have encryption. Also for say digital signal processing, okay, signal can be represented in terms of zeros and ones and can be processed, right. And also wide range of modern digital applications. All these you know very well, a computer is much faster. So, we would like to use computer for our calculations, or let it be any advanced applications we want to do, and computers they work in binary domain. That is the reason we have to study the binary number system. Okay. Now, both are very important, as we have seen in the previous slide. Decimal number system we humans use and binary number system the computers use, right. And if we want to give a task to the computer, we have to make sure that we need the conversions from the decimal domain to binary domain, and when the computer wants to convey the result it has computed to us, then we need to convert the binary back to decimal. Okay, and that is the reason we are going to study these two conversions in today's class. Okay, so let us start with a very simple example. We are taking a decimal number 17, here 17 to the base 10, as I told you deci, okay, means 10. So, it means this is a decimal number. Now, the question says we want to convert decimal to binary. So, this is the decimal number 17 that we want to convert to binary. Okay. So, the standard process is, remember, by stands for, okay, by stands for 2, correct, by stands for 2, we have discussed, right, shortly. Then what you need to do is just remember that every time you have to divide this number by 2, okay, and gather what is the remainder we get. So, first 17 if you divide by 2, the quotient is 8, right, 8. Okay, fine, but the remainder we get is 1. Okay, 8 to is 16, but we have a 17 here, so we will get a remainder 1, correct. Next, 8 by 2, you get 4, you know very well, there is no remainder, okay, so 0. Next, 4 by 2, you get 2, very simple computation, okay, and we don't get a remainder, right, because 4 is divisible by 2, fine. Then 2 by 2 we get 1, correct, and of course no remainder. Now, if you divide 1 by 2, okay, 2 0 times is 0 and you get, okay, so quotient you get 0 and the remainder we get 1, fine. Now, here you write down the bit positions starting from 0 onwards till the last digit, okay, the last digit is here. So, we will label 0, 1, 2, 3, 4, okay, fine. Now, what you need to do is, you need to write these numbers in that order, okay. So, you will start writing these numbers in the given positional order. Okay, so starting from bottom to top. The first digit we got is 1, so we are going to write a 1 here. The second digit we got is 0, so we are going to write that 0 here. Third digit again 0, we are going to write this 0 here. Fourth digit again 0, so we are going to write this one here. And then last is 1, we are going to write this 1 here. Okay, so that's all. We have completed conversion of the decimal number 17 into binary form. Here we are indicating base 2, means it is the binary number. Okay, so the binary equivalent of 17 is this 10001. Okay, next what we are going to see is we are going to discuss the next one is binary to decimal number. So question is convert this given number. So this is base 2, here it is mentioned base 2, means this is a binary number. We need to convert it to the decimal number. Okay, so now the standard process. Okay, so before we start discussing this, let us look at the previous slide what we did. Okay, when converting decimal to binary, we continuously divided by 2, right? So logically, if you want to convert from binary to decimal, you need to continuously multiply by 2. Simple logic. Okay, here we divided, right? Here we divided, so there we are going to multiply. So what we need to do is we need to continuously multiply, okay, by 2. So for that, easy method that we are going to take is we are going to write down these numbers. Okay, so this is the given question, right? So this one is the given question. We need to convert this to decimal form. Now what you need to do is on top of this, for our convenience, okay, it is not necessary that you will always should write on the top, but for your convenience you can do it. You start writing numbers 0, 1, 2, okay, 3, 4. And if suppose if you had few more digits, then you would have got 5, 6, 7, so on. Okay, here we are ending with the digit, right? And that is the reason we are stopping at 4. Now let us see why we are doing this. Again, if you see in the previous slide, okay, we have considered bit position. Fine. In the previous slide, we have considered bit position, and here I told you that we are going to use bottom to top approach. Means fourth position we are writing here. Okay, fourth position we are writing here. This is third position. Okay, and second position we are writing here. Okay, and first position here, 0th position here. Fine. And that is the reason now see it is like we are whatever steps we have taken earlier, we are reversing those steps, right? So this was our last step. Now it has to be our first step. So what we are doing here, when we are converting binary back to decimal, okay, what we are doing here, we are writing these weights on top. Next, here actually these are positional weights, and what you need to do is when we have 4 here for example, okay, actually you will consider 2 power 4. Fine. The reason being we have been discussing that here we were continuously dividing, and then so logically here we have to continuously multiply. Okay, so 2 multiplied 2 into 2 into 2 into 2 4 times will give 2 power 4, right? So that is the logic. When we have 4 here, actually we will take 2 power 4. When we have 3 here, we will actually take 2 power 3, and that is how we are going to proceed. So as we have been discussing, so here we have 4, so we will take 2 power 4 into this digit, okay, right? So that is going to give us 2 power 4 is 16, 16 into 1 is 16, right? So next case, Next case, what we need to do? This one, 2 power 3 into 1. Okay, 2 power 3 into 1 gives us 8. This one. Okay, right. Next, third case, we are going to take 2 power 2 into 0. Okay, so 2 power 2 into 0. Very easily we can compute this. 0 into anything is 0. So the result you are going to get is 0. Fine. Next, here after this we have 1. Okay, so 2 power 1 into 1, right? So that is going to give us 2. Then last case we have to consider 2 power 0 into 0. 2 power 0 into 0. So 0 into anything gives 0, right? So that is the reason we are going to get the result as 0. Now, so these are all the continuous steps that we are going to do, right? So first we are going to multiply with 2 power 4 into 1, then 2 power 3 into 1, then 2 power 2 into 0, 2 power 1 into 1, 2 power 0 into 0. Next, what we should be doing is we need to add all these. Okay, right? So 16 plus 8, 16 plus 8, that should give us 24. 24 plus 0, okay, no change, plus 2, 26 plus 0. So the answer we are going to get is 26, right? So now we have seen both cases. In the previous slide we have seen decimal to binary conversion. In this slide we have seen binary to decimal conversion, correct? Now how do we know whether the answers are correct or not? Let us go back to the previous slide and let us identify whether is there a method where we can identify the answers are correct or not. Yes, there is a method. That is, I will expect students in your exam, in your rough column, okay, do this only in your rough column. Okay, do this only in your rough column. So what you will do in your rough column is convert this, try to convert this back to the decimal domain. Okay, question didn't ask, but for you to be sure about whether the answer is right or wrong, try to convert this back to the decimal domain and you have to get the answer 17. Okay, so how do we do that? First you take the weights 0, 1, okay, you take the weights 0, 1 and then 2, 3, okay, 4, right? We are repeating the same process which we have seen in the next slide. And now what you need to do? 2 power 4 into 1. Okay, so 2 power 4 is 16. 16 into 1 we are going to get 16. Okay, 16 into 1 we are going to get 16, right? Then next 3, if you see, you have all zeros, 3 continuous zeros you have, right? So that is not going to add anything to the result. Fine, you can avoid computing that. Then last one, if you see, you have 2 power 0 into 1. For this you need to consider, okay, 2 power 0 into 1. So 2 power 0 into 1 is going to give us 1. So 16 plus 1. Are we getting 16 plus 1, 17? Yes. Okay. So this is how, once you complete the answer, you can quickly verify. How did we get this? 2 power 4 into 1 we did. Okay. 2 power 4 is 16. 16 into 1 is 16. So that 16 we are taking here. And following 3 zeros. So that is not going to contribute to our result. Then if you see this part, okay, this part, 2 power 0 into 1 is 1. So that 1 we are taking here. Okay, that 1 we are taking here. So 16 plus 1 is giving us 17. As I told, this you can do only in your rough work. Okay, because question never asked us to convert back to decimal, right? This is only for verification. Okay, then so we have seen both methods. So likewise you can also here, okay, in this slide we have seen how we can convert the, say, our decimal number to binary, and then I will leave this to students, that is convert this, okay, decimal number back to binary, and you should get back this. Again, do it in your rough column so that you can be sure that your result is correct. Okay. So in today's class we have seen, okay, binary number system, decimal number system, right, and the requirement for why we need to convert decimal to binary, binary to decimal. All this we have seen. Okay. I hope it was very useful. Thank you so much.